Okay, pre-cal, we are going to talk about solving polynomials. This video kind of culminates into this idea of why have we been doing all of this other stuff? Why have we been listing possible rational roots? Why have we been learning about synthetic division and long division? Well, this is the reason. All right, so the first thing we're going to do is we're going to list the possible rational roots for this particular polynomial. And that's going to give us positive and negative, and then all of my factors of 30. So 1, 2, 3, 5, 6, 10, 15, 30. And then my leading coefficient is 2, so 1 and 2. So this is what this would look like. So I'm going to have 1 over 1, 1 over 2, 2 over 1, 2 over 2 is 1, so I don't need that one. 3, 3 halves, 5, 5 halves, 6, 6 divided by 2 is 3, I already have that. 10, 10 over 2 is 5, we've already got that. 15, 15 over 2, 30, and then 30 over 2 is 15. So there's a lot of these, all right? This is the worst case scenario. So I want you to notice here it would be quite daunting to begin trying all these values until we find the ones that work. So we have a trick called the trick of 1. So we're going to look at that. What does that look like? So to use the trick of 1, you are just going to take all of the coefficients in your polynomial. So these values right here, including your constant. So you're going to add all coefficients and the constant together. So that's the first thing you're going to do. So for this particular problem, I'm going to add these, and the signs go with it. So 2 plus 21 is 23, 23 plus 7 is 30, 30 minus 30 is 0. Now, the next thing you have to pay attention to for the trick of 1, if the above sum equals 0, then 1 is a solution. And alternatively, if it does not equal 0, 1's not a solution. So that's why we call it the trick of 1. All right, so as we're looking through here, we're going to look at example 1 right here. We're going to find all the possible rational roots, then we're going to find all of the actual roots. So I'm always going to start off with finding all my possible rational roots. So I've got my factors for 6 in the numerator, my factors for my lead coefficient of 2 in the denominator. So I've got plus or minus 1, 1 half, 2, 3, 3 halves, and 6. All right, so those are all my possible rational roots. The next thing I'm going to do is try the trick of 1. All right, so I've got 2 plus 11 minus 7 minus 6. So 2 plus 11 is 13, 13 minus 7 is 6, 6 minus 6 is 0. Yay! That means x equals 1 is one of my solutions. And if you'll notice, the degree of this polynomial is 3. That means there are 3 solutions, so I need 2 more. Well, if I know that 1 is a solution, I can use 1 in synthetic division, because remember what happens when I divide. If I'm dividing a cubic function, a degree of 3 polynomial, then my solution, okay, what I get down here will be a quadratic or a degree of 2 polynomial. That's what I need. Let me show you why. So I'm going to bring down this 2. 2 times 1 is 2. That's 13. 1 times 13, that's 6. 6 times 1 is 6. And I would expect that to happen because I already know 1 is a solution. That's why I got a 0 right here. All right, so now what I have is 2x squared plus 13x plus 6. The reason we want a quadratic is because a quadratic puts us in a nice position, because the quadratic now can be solved. Even if it can't be factored, we can always use the quadratic formula to solve it. This particular situation is going to factor. So I've got 2x and x, and I've got 6 and 1. So the 1x and the 12x will give me 13x. Then I set each of my factors equal to 0. I solve. And then there are my 3 solutions. So x equals 1 is a solution, x equals -1/2, and x equals -6. I've got 3 solutions. Awesome. All right, so where does my possible rational root theorem come in? Why do I have to do these? Well, I'm about to show you. So if you will look down here, right here, I've got some information for you. So where do we start when trying to find all the roots? Well, here's the thing. If we've got a degree of 3, we can try to factor it using grouping. More than likely, that's not going to work, but it can sometimes. If the degree is 2, we can try to factor it, or we can use the quadratic formula. Remember that the quadratic formula always works on a quadratic. Even if factoring will also work, the quadratic formula will still work. If the degree is 3 or higher, we can't factor, so we have to find all the possible rational roots. So that is the very first thing we're always going to do when we're solving these. We're going to find the possible rational roots, and then we're going to do the trick of 1, because it tells me that either 1 is a solution or it eliminates 1 as a solution, and then I can move on from there. And you need to make sure you read all of this, but I'm going to address all of this in the coming videos and in your next examples.